So we will go ahead and get started. People will slowly start trickling in. Welcome everyone. My name is Timothy Randhir. I'm a professor at University of Massachusetts, also organizing this global symposium, along with three other coordinators here, Dr. Tirunavakarsu from Tamil Nadu Vet and Animal Sciences in Chennai, and Dr. Belina Xavier from Stella Maris College in Chennai, India, and also Dr. Renu Randhir from STIC at Massachusetts. So as I was mentioned in the brochure, the program is in the auspices of International Association of the Study of the Commons, and we have hundreds of local events happening all over the world as a part of the the Commons Week. And so we have a variety of topics and lined up for you. And so I will be I'll be starting off the first keynote speech here, just to kick us off in this day-long conference. And so I'll be talking about a much more broader scale involved in conservation policies across multiple scales. So as a reminder, so we have panelists on one, will be seen on the video, but attendees, if you have any questions or you're always can interact right from the from your screen, especially you can hand raise. You can also participate in the chat boxes, and we will try to actually get back to you on any questions you direct to the speakers. So with that, I'll start off my talk. One of the important aspect of commons is they have a very unique feature of not excludability, as well as it has some sort of a interaction between the agents. So our policies across any type of a resources, whether it's a water or land or climate change or resource use related to agriculture or veterinary sciences, involves a little bit complexity. So I'm going to actually talk about a few basic concepts and approaches we can use for these policies. So this is a mosaic of a variety of things which could happen, especially when we are talking about natural resources, especially if you look at the amount of population increases and the nature of emerging issues related to soils, water, air, biodiversity, the emergence of extremes like the droughts and floods, often it needs new approaches for it. For those who are not on presentation, you can mute your audio. So here is a recent mapping which was done in terms of the risk involved in to the human society. So one of the highest is, you can see that along with stock market and fiscal imbalances, we have food shortage, water crisis, right on the top, having the high amount of risk in terms of what a society will be facing. So how do we address that? It's usually addressing them as complex behavior. So complexities usually arise when you have too much of interactions, too much of hierarchies involved, and there's also the nature of adaptation and number of scales involving that complex system. And so in order to address these types of systems, there needs to be a different type of an approach. And so here is a representation of this particular scale. So here you have a, as your number of scales increases, and also the number of this is the scale size of the scale, you tend to see the complex system has multiple corrections, and it also emerges over time into new emergent behavior. And chaos also operates in those scales. So there is a need for a paradigm shift in these types of conditions. One is many of the current traditional way of systems should not, traditional way of approaches should not be used, but rather a shift in the paradigm. So from a disciplinary to a transdisciplinary, a component-based approach to a systems-based approach, a static type of approach to a dynamic one, from a site-specific to a landscape approach, and from short-term to sustainable long-term approaches. So given that one, so how do we address the conservation policy under the uncertain? I think that's the topic of today, which is in uncertain times, how our conservation policies should emerge. So this is the typical theoretical approach of how we address some of the choices when we make under uncertain conditions. So we usually use a specific experiments and uncertainty in choices, and there's a rich theory behind how expected utility can be used to study choices under risk. But the important thing is the same framework can be used to develop policies which can address some of the choices we make under risk. So one aspect or the emergence of this expected utility is the multi-attribute utility. That means we are also looking at not just choices involving one outcome, but there's also choices involving multiple outcomes. So when we think about multiple outcomes, then the nature of the behavior start to become more complex. So multi-attribute utility theory is another approach of how we develop conservation policies related to those involving multiple benefits and outcomes. So I will give some examples on these types of conditions on how we can develop some policies. So important special cases which Keeney and Rife are developed is when we have independence of attributes is some sort of a basic assumption, but we also sometimes the utilities can not be independent, but they can be joint. So I will be, this is my approach, which I usually use in my research, is primarily looking in a multi-attribute optimization framework, trying to achieve multiple attributes, whether you're maximizing income or minimizing pollution, but subject to a particular system conditions and also some boundary conditions. And this way to, approaching some of the uncertain conditions often helps us to develop unique ways of choices which can handle multiple attributes, especially when we are facing risk. I'm going to give an example under the climate change uncertainty. So often under climate change, our choices are involving, so for example, the whole biophysical system on the top, that's a climatic system, involves multiple flows and also multiple stocks. But the main thing is, how does our Earth system react? And so there are two places usually where much of the activity is happening. So for example, much of the choices involving climate change involves this circle, which is on the at the interface between the atmosphere and the land and the oceans. That's where a lot of choices related to land use, choices related to policies on conservation or water use, all these things happen in this circle. So so here is some projected implications of different impacts of this climate. One is the risk involving related to food systems. As your higher and higher temperatures have higher and higher uncertainty related to achieving some of the targets. Same thing with water. You can see that at a smaller increases, you have those components which have smaller amount, less sensitive, um, usually come at the right side of this matrix, but those which are highly sensitive will start to show up in even with small increases in temperature. For example, glacier melts or damages to the coral reef. All the way you can see that at higher and higher temperatures, you tend to see irreversible changes happening as we go along with higher temperatures. So general direction of how we approach this is using ecosystem services. So ecosystem services related to a variety of these outcomes coming from increases in temperature or changes in your precipitation can be tracked in these types of. So here is the color coding is level of impact, but also the direction of impact. So many of them, those which are associated with climate impacts, you can see that they are rapid increases in impacts. And even though this one is a direct impact, you have also other indirect impacts happening to other areas of the ecosystem services. So another important one related to the cost involved. So often we see that this is the inflation adjusted cost involved in extremes, weather extremes. So you can see that in the past couple of, I would say, decades, we have been seeing increase in the number of events, but also the losses incurred are also becoming high. So this is the regional scale impacts on how many people are affected in different continents. And especially when we have those which are already existing stress in watersheds, the amount of impacts can proportionately go higher because of the climate change. So how do we address this as a policy? There's a variety of concepts involved. So here is on the left-hand side, this a diagram on adaptation, mitigation, and impacts. So the type of adaptation and also the cost of mitigation and the cost of the impacts can be tracked, and any type of policy can try to minimize a combined cost of all these aspects. So we are also seeing the changes in the cost of in terms of GDP in different regions defined by the World Bank. And again, this is the cost of adaptation also is variable in different regions, and this is also a very important one in terms of developing conservation policies. So in the bottom figure talks about the amount of increases which are happening in terms of risk. So these are extreme likely probability versus extreme outcomes and damages. And again, this one is a very important one as we develop policies related to uncertainty related to climate. Moving on to the another important subject is the food security. Again, food security has been a big concern related to variation in production regimes. So here is a prediction on the potential losses in 2030s in a decade from now. And the thing is, the range of yield losses and also the range of decreases in yield, which are in the yellow portion of this bar graph, are substantially expected to increase. And that is the yield of both crops and pasture are primarily going to be affected in almost all the continents within a decade, I would say. So these are some specific impacts on prices. Again, going back into the economies, price increases of some of the basic commodities needed for many countries also are expected to increase from staple crops to all the way to any type of crops, the prices are going to increase because of a much more higher implications on the production systems, but also scarcity related to less supplies. And one important one to look at is who are affected, and most of the time it's the poor who are affected by these impacts. I'm going to quickly go through some of the material because I'm running out of time. So water stress is a very important one. This is an example in the US. And it actually exacerbates the stress, the climate change exacerbates the stress. This is the same situation in many countries. Again, these are other implications related to agricultural productivity, change in frost-free seasons, a number of hot nights, consecutive dry days. All these have big impacts on yield systems. Again, this is in California Central Valley, which is a big producer of a lot of commodities. Again, we are seeing huge increase in or change in the impact on the crop yields. In terms of a variety of implications related to different continents, we have some which are going to have a much higher impact in some basic commodities like wheat, rice, maize, soybeans. This is the lower scenario, RCP scenario, and then there's the higher concentration scenario. In both the cases, we tend to see a high amount of losses in yield. And so how do we deal with some sort of uncertainty? So one example of a study which I did in New England is the nature of uncertainty, just to study the nature of uncertainty related to space and time. Here we are talking about a large region in the northeast of US. So spatial influence, how uncertainty impacts over space, but also how it emerges over time. It involved a very complex calculation of all the changes which are happening coming from the global climate models, but also using geographic information systems to study the space-time distributions. So here is space and time implications or in the future. We can see that there is so much of local as well as emerging. This is the time trend is over time is predicted to have a huge amount of space and time uncertainty. Just zooming out into variation, there's also expected to have huge amount of variation over time, but also over space. So in terms of water quality, we see that many of the impacts on water quality are directly related to runoff, but also nutrients. And one important aspect in recent study is in Bangladesh arsenic. So this is a framework which is a different one from traditional probability approaches. This is a surprise uncertainty. So how do we incorporate surprise, and how do we make decisions when we have something which is surprising to us? Like, say, for example, the black swan phenomenon we saw, which I showed you in the previous slide. The black swan is primarily, we don't have any previous information to study probabilities. And in those conditions, often we need to use a different approach. And this is a surprise framework which I wrote a few years ago, along with my colleague, Dr. Mazumdar in Florida International University. So we applied this framework to Bangladesh, which essentially uses a variety of conditions which are different from probabilities to see how we can actually make decisions when we are dealing with uncertain scenarios. So the application here is three choices. One is, should we go for shallow wells, or we use surface water or go for deep wells, which has the least amount of uncertainty. And so we applied this method to the Bangladesh water case. And one thing we found is it resulted in a suggestion that the options which we among those three have to be some sort of a diversified in terms of reducing the surprise levels. Another important policy aspect is many of the regions we don't have information. So what do we do with that information? So here is a watershed in Russia, which we try to actually look for understanding, what is the hydrology behind it. And in this case, we have to develop our own information from remote sensing. So this was, remote sensing was used to calculate runoff, different evapotranspiration levels under different climatic conditions. Another example is, this is in Orinoco in Colombia, Venezuela region. Again, we don't have much information, but we were able to capture a lot of this information from remote sensing, which you could use in conservation decisions and policies. So here is a ecosystem service index, which we developed for the Orinoco River. So in terms of approaches, so one thing is a multi-scale adaptation and resilience is something suggested in the what happens is resilience is how a system quickly comes back to to its original condition after a shock. But in order to study the multi-scale nature of that adaptation, we need to look at this system as multiple scales. So there are specific aspects of the socio-ecological system in terms of persistence, change, sometimes unpredictability, and another aim for any type of a conservation policy is to allow them to self-organize. So for example, any type of a disturbed system, they have to self-organize through their own specific components re-emerging to actually come back to the original conditions. So this is a multi-scale ecosystem framework, which is the framework which forms the fundamentals for this whole conference. This was developed by me a couple of years ago. The nature is when we have socio-ecological systems and ecological systems are governed by multiple scales, we have a very unique challenges which are happening both within a system, but also which transform into multiple scales. An example is, for example, the COVID-19 case. So you have a shock at a global scale has multiple repercussions which go into the local scales. And also it has huge implications on both the socio-ecological systems, but also in the environmental system itself. So again, this system is not just multiple scales in space, but also time. It also has a short-term and long-term possibilities. So what are some of the policy options? So some of them is trying to tackle the incentives for the agents. Some trying to tackle the property right allocations. Sometimes it's a direct regulations, financial incentives. These are very common type of instruments used in policies, but these have to be altered to incorporate the scale effects, but also temporal effects. So another important one we think about is these climate stabilizing wedges. The stabilization wedges are primarily looking at the changes if we double and the increases in wedges and trying to actually bring it back and slowly, and then breaking it into this triangle into smaller wedges to avoid and trying to calculate how much is the cost involved and the policy implications of each one of those wedges. Again, this is a cost curve of different types of policy approaches. Again, this is for greenhouse gas abatement costs, from all the way to high cost industrial approaches like biodiesel or capturing carbon, to all the way to a lower type of lower cost involved in simple building installations. So you can see that some of the costs are lower, some of the costs are substantially higher, but we have all the options in terms of approaching it. Again, every policy have to be evaluated in different ways in terms of voluntary or and the information. So you can see that economic efficiency, environmental effectiveness, equity is usually a bigger challenge in a lot of policies, and then administrative feasibility and political feasibility. So, so these are different options mapped against these different evaluation charts. So quick conclusion, a multi-scale response to any type of a conservation need has to evaluate technological but also institutional social aspects so that we can develop adaptation and mitigation options at every scale. Often conservation happens from a smaller scale to all the way to global scale. So we cannot address starting with one scale and then forget the local scales. So they have to be connected dynamically. So one important challenge in uncertain times is early warning systems and disaster management systems. This is another important research area. I'm trying to actually see how we can actually get the information in a timely manner. Another area of option is policy is they're trying to reduce the uncertainty using a variety of practices which can minimize uncertainty. And then the role of people in terms of trying to adapt. And lastly, one of the final thought is systems are connected. They have to be aimed for robustness, and they also need to be adaptive. So I'm going to stop there, and we are going to, so if you have any questions, feel free to actually share it on the chat box, or you can always raise your hand.